This looks very good, guys. What do you say? Hey guys, Lucas here and welcome back at K's New Space and welcome back to KSP. Today we're going to write a little flight computer for this rocket here. It is inspired by, well, a little bit of Starship and those old school rockets. It also carries a little payload. Wait for it. But jokes aside, this is actually quite the serious video because we're going to do some serious coding. So the first thing I want to do is to go over the code we've written last time. This is it. I improved upon a little, but it's mostly the same. Okay guys, we first import some standard libraries. As you can see, I annotated it a little. For example, here you can see it ships with Python. We also import a non-standard library, keyboard, which we had to install. Then we've written a function which allows us to move and change the visibility of the cursor on this console window here. This is the cursor. It writes stuff to the console. Okay, the next commands are new. System is a function from the library OS or operating system. It allows me to execute terminal commands from Python. CLS, for example, is, well, it's the same as clear I've used before. CLS allows us to clear the screen. So every time I run the program, I have a clean screen. And I had to print a new line after that because for some reason the cursor can't move to the highest position. It ends up on the second. Which means if we start at the first line, we can't get rid of this one here. So this will print double. I can maybe test it later. And this here is also our main program loop. This is where all the magic happens. As you can see here, we wait for a key to be pressed, escape. If we press it, the program ends by turning this quit value true, which simply stops this while loop. While not true is false, so it stops. The statement in here has to always be true in order to keep going. And this here is the improved UI for our little flight computer. I print a couple lines, an arrow, a title, and here the timer we had last time. And this sleep function is of course used to limit how often our loop runs per second. Without it, it would completely spam our computer with commands. Also, as I have found out, is KSP only has a limited amount of physics time, so if we ask for data too often, it runs into issues. The lowest value I found for DT was 0.03. Lower than that and it goes bananas. Okay, let's give this little program a try. Python main.py. Yeah, and I also renamed this to main.py. Why? You'll see in a minute. And this is how it looks. Quite nice, I have to say. Okay. So as I've mentioned, I renamed the Python file to main.py. Why is that? Well, because I want to keep this main file as clean as possible. And that's why I will offload all the functions we write, like cursor move, into a new file. And that new file will be imported into this one. Let me show you how it goes. First, we create a new file. Like we did the first time around, I write an empty string into a new file that doesn't exist. Windows will automatically create a new one. I simply name it k.py. Okay, this k.py we have to now open. Here we are. And I will simply copy and paste my cursor move function in there and save it. Now in the main file, remove it, and like we imported our libraries, we import K. That's it. That's how you split software into multiple files. We can test it again. Oops, we have a small error. What is that? Cursor move 5 up. Cursor move is not defined. Ah, yes, well, we import k, so in order to use the function now we had to type k.cursorMove. However, to avoid that, we can simply from k import star, which means everything. So like our other functions, we don't have to use the library name in front of it anymore. Let's try it again. There we go. Now what I've also just noticed I changed is in the cursor move function I added a direction instead of using positive or negative values because it's just more readable. So if I want to move the cursor up, I type in a number by how many and either up or down. And in the function I check if direction is either up or is down, and then either use this command to go up by n or go down by n. I hope that is clear. Now guys, if you ever have a question, please simply ask it in the comments. I will always try to answer it. Okay guys, so how do we control our rocket using KRPC? As we've done in the very first video, we first have to import the KRPC library. And now we have to connect to KSP using it. So KSP equals to krpc.connect. And in the braces we add a name for our connection. Let's simply call it main.py. And right away let's check if it works. I open the KRPC window. Right now you can see no clients are connected. Oh, it looks like I have a typo, and sure, I used the wrong keyword. It's import, not from, because now I'm importing the whole library. Let's try again. Main.py is connected. Now the next step is to get hold of our vehicle or vessel. This is done by calling ksp.spacecenter.active vessel. This command will return an object, and this object is our vessel. It contains all kinds of information like the name, the altitude, the throttle settings, and so on. And of course we can't not only read but also write it or change it. So let's try that right away. First I'm going to use the name of our vehicle, and I will use it in the title. Flight computer for vessel.name. And of course I have to change it into a formatted string again to use a variable. Okay, let's test that. Flight computer for small ship. Nice. Although now I need longer lines. You know guys, I'm also always about making it look nice. And this looks good. Next, I also want to print out the throttle setting. For that I simply copy this line, call it throttle, and we can access the throttle by vessel.control.throttle. This should do it. Ah, wait. Now, because we added a new line, we have to also move one more line up and one more line down. Otherwise our UI gets wrongly overwritten. Okay, let's check it out. I changed the throttle. Oh, even lifted up. Okay, as you can see, it goes from 0 to 1. So I also want to change that. I want to actually have it in percent. So all we gotta do is to multiply our value by 100 and add a unit. I think we also don't need decimal places now as we use percent. Let's try it again. Oh, can you see it? It not correctly overrides the percent unit. Why is that? Ah yeah, we have to keep in mind we only replace the letters we actually overwrite. So if the text we use to overwrite is too short, we won't. So to fix this, I simply add some additional lines to the end here. It's a bit hacky, but it works. Let's try again. Great. Now the next step is I want to actually change the throttle using the flight computer. Now for the flight computer I will also write its own function. And it will simply be called flight comp. Define flight comp. And of course, in order to change the throttle, I have to hand it over to the function. Vessel.control. Here I will call it the controller. Now this controller has access to throttle, to pitch, yaw, and all the other controls. Controller.throttle equals 1.0. Oh wait, let me not go full throttle. Okay, let's test it out. As you can see, 20% throttle, it works. Now in order to reach a certain altitude and hold it, we of course have to track it. That telemetry is also part of the vessel object. It is vessel.flight. However, a lot of telemetry is relative to something else. For example, the speed. Speed only has a meaning if you compare it to something else. For example, the surface. What this all means is this particular object requires a reference frame. Sounds a bit complicated, but all we have to do is to add the vessel's own surface reference frame. The name surface reference frame is actually a little misleading because it does not actually mean the surface of the planet. What it instead means, the surface of the vessel. So this reference frame moves with the vessel as we fly up. So we can use it for things like altitude, but speed won't work. That's why we have to calculate the speed ourselves, but that's no problem. So let's also hand the telemetry to the flight computer. Here and there. Okay. And the current altitude is equal to telemetry dot surface altitude. Now to check if that works, we can also print it out. I again copy and paste this line. Telemetry dot surface altitude, and the unit is meter. Again, Move one more line up and one down. And that should work. .3 meters. As you can see up top it says 76, but that's because by default KSP actually shows you the altitude above the ocean. You can change that by clicking on this icon. So 2.3 and 3 meters, so it's about the same. Now what's left is a desired altitude. And I will simply set it up by pressing a key. Elif, key pressed. And I will press 1. And when I press 1, I want to increase the desired altitude. However, we haven't defined that desired altitude yet, so that's what we have to do next. I'll do it up here. The default value is 0. Okay, and I will also print out that on the screen. Like so. We can again check it. Oh, we have an issue. We forgot an S, I think. Yes. Oops. I knew that would happen one day. Now it works. And pressing 1 adds 100. Wait a second. It adds more than 50 because I'm too slow, so it actually runs multiple of these iterations while I press it. So I have to simply add a little pause. Sleep for half a second. Let's check it again. Not perfect, but it gets the job done. Okay, now comes the interesting part. I want to increase the throttle if our current altitude is lower than the desired one. And for that again, I have to hand the desired altitude to our flight computer. Remove that line, that was just for show. So, if current altitude is smaller than desired altitude, controller.throttle. You know what? I start simple. I simply put the throttle to full thrust if the altitude is lower, and then else if it's not lower, if we're above the desired altitude, I will drop the throttle to 0. Now let's think for a moment what this will do. We will launch up, fly to, let's say, 50 meters. The throttle will shut down. The engine will shut down. It will actually overshoot, I think. It will drop back down. And then once it again hits 50 meters, it will go full thrust again. And, well, I think it might start to oscillate back and forth around 50 meters. Or whatever desired altitude we choose. Let's try it. And let's go for 100. Oh. Okay, for whatever reason my cargo bay opened. Okay, this is not good. Because we turned our engine off, we have no more control over it. And of course... Ouch. Now pointed in the wrong direction. Okay, let's try that again, but instead of dropping the throttle to 0, let's try 2.0. And that works better, but of course we overshoot it by a lot. Almost 500. God, I think we might actually smash it to the ground. I'm not sure if we can slow down quickly enough. I increased it to 150. Okay. I think this might take all day. So what we are running into is a very common problem in control theory. We oscillate back and forth around a desired value. Now, in order to prevent that, what we can do is to decrease the throttle the closer we get to the desired altitude. For that, we actually have to calculate the difference between those values. So difference in altitude is equal to desired altitude. Oops. Minus oh wait, I already have it. Current altitude. So if this is 100, this is 0, the difference will be 100. Let's use 100 as the maximum throttle. If diff altitude is larger or equal than 100, we want to set the controller throttle to 1. But if it's actually lower, let's say only 50 meters, we want to set it to 2.8. And let's do another one. If it is between 30 and 50, let's do 0.7. I actually haven't checked how much I need to fly at all, so let me quickly do that. Okay, that's like 50%, gets us in the air. Oops. I think that were our lights. So let me do one more. If the difference is, let's say, between 20 and 30, do 0.6. Okay, this should in theory already improve our flight computer a lot. Let's test it out. 100 again. I don't know why my cargo bay keeps opening. Yeah, we don't fly to 500 anymore. Uh-oh. Now we could tinker around with these values for hours, and I think we would actually come fairly close. However, there is an underlying issue. The issue is in the lower left corner. our mass changes with time, which means whatever cool values we come up here, it becomes completely obsolete just a minute into flight. What that means is using the altitude and the throttle alone won't get us anywhere. We need a step in between, so to speak. And that step in between is our speed. So in essence, instead of controlling our altitude with our throttle, we will control our speed, and we will control our altitude using speed. So first we have to find out, how do we calculate the speed? Well, luckily that's quite simple, because speed is nothing but a certain distance we traveled over time. And the distance we travel is of course the altitude, or the change in altitude between two time steps. Let me paint this on screen, guys. We start at some altitude 1 at some time t1. Then some time passes until we reach time 2. And at time 2 we have altitude 2. So in order to figure out how much altitude we gained, we again subtract one from the other, like we did previously. But what's the difference in time? We could also subtract that, but we don't have to, because we already know it using dt. That's the time that passes between two altitude records. So all we have to do is to somehow keep track of the last altitude we had before we calculate the new one. So all we have to do is to keep track of the last altitude we had. And that is simply done at the very end of our while loop. Last altitude equals so the last altitude is our current altitude before we pause the flight computer. And then when we loop around, we feed our flight computer with the new current altitude and the old one. Now both of those values have to be created. The current altitude is easy. We can also use this value over here. And over here now. The problem now is the loop itself cannot remember last altitude because it was created inside the loop. So like the rest, we have to define it in front of it. I simply put it here. Some initial value, it doesn't really matter. So now that the variable was created outside the loop, writing it here writes it there. I hope that makes sense. In programming terms, this is called a scope. So the scope of this variable would end outside the while loop if it wasn't created outside of it. So now that we have both of those altitudes, we can calculate the speed. Oh wait, we also need our dt. Okay, that should be it. Now, wait a second. We don't need that line anymore. Okay. Speed equals current altitude minus last altitude, and all that divided by dt. If you think about it, it makes perfect sense because altitude has a unit in meters and dt has a unit in seconds. So meters divided by seconds is meters per second. That's all there is to it, guys. It's math, but it's the simple kind of math. So now I'm going to change the entire logic here because we want to keep track of speed. The idea is to lower the speed the closer we get to the desired altitude. So first I will also make this a little bit shorter because like dt, dA is also a difference between two values. Looking at dA, I directly know what it stands for. So what we now need is some kind of speed limiter or max speed that depends upon the difference between the desired and the current altitude. It sounds more complicated than it is, but I'll do a separate function for that so that our flight computer doesn't get so messy. Get max speed. So this is pretty similar to what we did before. If dA is bigger or equal than 100, first we have to define it again. Okay, if it is bigger than 100, we want to keep the max speed pretty high, let's say 100 meters per second. Now, the closer we get, the slower I want to fly. Let's say 50 meters per second. Copy and paste this a bunch of times. At 50 distance, I want to have 30. At 30 distance, I want to have 15. I mean, you can do it as detailed as you want, but I'll keep it at 5 values, I think. And I drop it to 5 meters per second. And now in our flight computer we will use that max speed to change the throttle. However, instead of keeping track of the altitude, we will only use the speed. So if speed is bigger or equal than get max speed, we want to keep the throttle low. Controller.throttle 0.2. And if the speed is below our max speed, or else, we want to keep it high. And of course, we need some kind of minimum throttle setting to be able to steer. So what should happen now? The flight computer is supposed to change our throttle. For that it will check how our current speed compares to the max speed we can have based on the difference in altitude. It will then either use a low throttle setting or a high throttle setting. Let's just try it out. I somehow doubt that it will work on the first try. Okay. We have an issue in line 39. Ah yes, right. I think we forgot to return the max speed value. So if you return it, wherever we called the function, this value will be inserted. So if speed bigger or equal to max speed. Now it should work. God, what is it? Okay, something is happening, but we should not be going up because our desired altitude is actually 0. However, let me just increase it for testing. I mean, it sort of works. Okay, we're at 50 now. And we'll keep going up. I'm not quite sure why. Okay, let me try to land this thing. All manual. Okay, so what is going on? I think the issue is we don't deal with negative values. If we surpass our desired altitude, this value will become negative. That's a little bit trial and error now, but I think I need to differentiate between positive and negative dA here. So if dA is bigger than 0, do this, and else, so else if it's smaller, we want to reverse the speed. So if our speed is faster than minus get max speed, we want to reduce throttle. And if our negative speed becomes smaller than get max speed, than minus get max speed, we want to throttle up. I think that makes sense, but I'm not quite sure yet. Let me try. Nope, we're still going up. We shouldn't. I'm a bit confused, guys, so let me add the speed to the telemetry so that I know what's going on. However, we calculate the speed inside the flight computer, so let's calculate it outside of it. Now add it here. That's meters per second. And I think inside the flight computer we don't need our DT anymore. And we also don't need the last altitude anymore. I hope that's right. Desired and current. Right. Okay, let me try that again. Oops. Okay, I will fly manually this time to check if it works. Well, I can't fly manually. Okay, let me add 50. Now it definitely goes up to 50, I think, and reduces the speed. Now it should hover around 50. But but it continues to go up. Let me land it again. Let me switch that around here because I'm confused by that. So if the speed is smaller than minus max speed, I want to throttle back up to make the altitude drop more slowly. Otherwise, I want to drop more quickly. I think that was not the issue, but let me still try. Nope. Maybe it has something to do with max speed. Let me try to add some smaller values. Maybe the smallest one is just too much. 3. 2. And one more, why not? So if we come within 3 meters, we will fly at 1 meter per second. And maybe 100 is also a little bit too much. Let me at 80. Okay, let's try again. Why does it go up? Okay guys, I had to do some off-the-record tinkering. And as it turns out, the error is quite simple. Our getMax function, I use if statements. So if dA is bigger than 100, max speed is 80. However, if it's bigger than 100, it is also bigger than 80. It is also bigger than 30. It is also bigger than 2. Which means it will simply go down this line and always add the minimum value to max speed. The reason is I forgot to connect the if statements using else ifs. So now if one is true, it will skip the rest. So if the first one is true, it will skip to the bottom and return max speed. So it will go down the tree until it reaches something that turns true. This is the first of 2 issues. The second issue is our dA value here. It is positive when we are below our desired altitude, and it is negative if we are above it. So if this value gets negative, it will always default to the last one, because that's the last setting it had. It never becomes true. So what we have to do is to negate it. In this if statement here, the A will always be negative because we check it here. If it is bigger, it will go this route. And if it is lower than 0, it will go this route. So by negating it, we make sure it will always be positive inside the getMaxSpeed function. And what I also want to do, because we haven't defined any value between 0 and 2, I will simply use 1.5. That should do it. Oh wait, I could also simply use else. I hope that works. Now let's test it. Spoiler alert, I think I know what will happen. Okay, we remain on the launch pad because we are actually slightly over our desired altitude of 0. So it throttles to 20%. which is of course the minimum throttle we have set. Okay, let's change the desired altitude to 100. Whoa. Okay. We overshoot a little. And we are going down, guys. What do you say? Doesn't this look good? We are hovering, guys. And we are approaching 100. Okay, so one more thing we actually need is to reduce our value of the desired altitude again. We can only increase it. So let me quickly change that. I use another key. This time key 2. And decrease the desired altitude by 50. Now if we are quick enough, we can actually keep flying. Okay, yes, it works. Now let's decrease it to 0 and see what happens. Will we land? I can even steer a bit. Now the steering is all manual. Our flight computer only handles the altitude or speed. But it doesn't want... Okay, it doesn't want to... Oh. Okay, it seems like we have one remaining issue, and the issue is our minimum throttle on the way down is just too high, and I think our maximum throttle is also a little bit too high, so I will reduce those for going down. I'll keep the ones for going up. Okay, let's try again. Hopefully one last time. What is this here? This looks very good, guys. What do you say? Minimal oscillation, despite turning the engine on and off. But I am fine with that. Okay. And now the very cool part is, because our controls were completely independent, we can actually fly the rocket. And it will still keep the altitude. No matter what we do. Let's slow down a bit. Oh. Let's go to 100. Oh. Okay, I have to check my action groups, I think. Okay. Do you think we can land here? Oh, let's go to 0. Oh. Okay. Well, our payload survived. Isn't that all that matters? Okay, guys, I hope you had some fun coding with me. And the most important part now is try it for yourself. If you have any questions, please leave them in the comments. Okay? Auf Wiedersehen and thank you for watching.